So let's deal with this example problem. On the left, we see that there is a bent rod, and on the left, it is supported with a thrust bearing. So thrust bearing means a bearing which would not allow translational motion along the axis of rotation as well. So at A, we have, let's say, this is the x-axis. So we have AX, we have AY, we have AZ, and this being the y-axis. Just drawing it far away. Then, so that is AZ, AX, AY. Then we have the dimensions of this given as well. So this, the 80-pound force and TC, if you observe carefully, they're being applied 6 feet. So 80-pound force is 6 feet away from x-axis. Even TC, even that is 6 feet away from x-axis. And this 80-pound force, TC, this is 1.5 feet from y-axis, and TC is 1.5 feet from 80 pounds. So this is what is given in the problem. Now, by the way, this is the thrust bearing. And how many bearings do we have in the system? Just one. So the bearing would also provide a moment with respect to x-axis. That means, is it free to rotate like that? No, it is not. So you have a moment MAX, which is counterclock with respect to positive x-axis. That means if our eye is here, it is counterclock with respect to our observation, our point of view, which is located on the positive x direction. Similarly, we would assume this is MAZ, which is also an assumption of counterclock moment, assuming our eye is located on the positive side of the Z, right? But we don't have a moment with respect to y-axis because this rod is free to rotate with respect to y, and that's the purpose of thrust bearing. That's it. Now we have finished drawing the free body diagram. Now let's apply equations of equilibrium, which is sigma fx equal to 0. That implies what are all the forces in the x direction? We have ax, and that's it. We have just ax. So ax is equal to 0. Then sum of all the forces in the y should be 0, implies give me all the force in the y. Ay is 0. Just Ay is present along the y direction. Sum of all the forces in the z equal to 0 implies all the forces in the z are Az, negative 80, positive Tc is 0. That's it, right? Then sum of moments with respect to x-axis is 0. Implies, tell me all the moments with respect to x-axis. We already have max, right? We already have max. Max is, it is with respect to x-axis, it is rotating counterclock. So if you see our eye, with respect to our point of view, which is located on the positive x direction, it is rotating counterclock, and that is MAX. So our assumption is already counterclock, so I'm going to write MAX. And what about AY? AY is perpendicular to x-axis. What about AX? AX is parallel to x-axis, so it has no contribution towards moment. What about AY? AY is perpendicular to x-axis, but do you have distance between x-axis and AY? What is the distance between x-axis? Because this is positive x-axis, right? This is positive y and this is positive z. From positive x-axis to AY, is there any distance? There is no distance. AY is passing through x-axis. If AY was going like this, for instance, then you have that is the distance above x-axis. That means this is the distance above x-axis. So if I were to ask you the distance of AY, you would have given that distance. But now AY is on, AY is, oh, there's many things, I guess. See, AY is, okay, you see this? AY is passing through x-axis, so it has no distance. What about AZ? Same story for AZ. AZ is passing through x-axis, so it has no distance from x-axis. If AZ was here, for example, let's say AZ was here. AZ was there, for example. So what is the distance between x-axis and AZ? That would be the distance, isn't it? That would be, so if it was away from x-axis, so assume me standing here in the classroom. You remember I used to always say one side of the wall is x-axis, a side which is parallel to the whiteboard is y-axis, and the column, one of the pillars, is the z-axis. So if you remember that idea, let's say I'm standing exactly where 80 pounds is acting. What is the distance of 80 pounds from the x-axis? That means from the wall, from the plane that is passing through x-axis and parallel to 80 pounds. Where you would say that this is the distance. You would say that that is the distance. Give me a sec, it's syncing to OneNote. After it syncs, we will be able to see that. Yeah, so that is the distance of 80 pounds from x-axis, which is 6 feet, right? So if we keep moving 80 pounds towards x-axis, what happens to the distance? It reduces. Assume that I'm placing 80 pounds there. Then what is the distance between 80 pounds and x-axis? Zero, because we kept reducing the 80 pounds. We kept reducing the distance of 80 pounds. Slowly we are moving towards x-axis. And if we bring it back all the way to this point highlighted, then what is the distance? It is zero. So how do you measure the distance from an axis to 80 pounds? By observation, by taking a plane that is passing through the x-axis and parallel to 80 pounds. That being said, so with that idea, the question is, what is the distance of AZ? It's zero. What about MAZ? MAZ is moment with respect to Z axis, this MAZ. So we don't care about that when we're talking about x-axis. So What we are left with is 80 pounds. What is 80 pounds? 80 pounds is at a distance 6 feet. 80 times 6. What is the direction? Is it clockwise or counterclock with respect to positive x-axis? That means with respect to our I, isn't 80 pounds like that? And the direction is like this, which is aligned towards 80 pounds. That means assume it rotating with respect to positive x-axis. That means our I is here. So if we are observing the rotational effect caused due to 80 pounds, it is going to give a clockwise rotational effect. So we have to write this to be negative. What about TC? What about TC? TC would give a counterclock rotational effect because TC is going with respect to positive x-axis. We have like this. And what is the direction? Direction is already given by the direction of TC. So keep following the direction. So with respect to the IE, which is located on the positive x-axis, how is TC rotating? Counterclock. That means we have to give positive TC times, what is the distance? It is 6 away from x-axis is equal to 0. That is the moment with respect to x-axis. Now let's discuss the moment with respect to y-axis. Sum of moments with respect to y-axis is equal to 0 implies. So moment with respect to y-axis is, let's start with every force. What about AX? And y-axis, imagine y-axis. Where is y-axis? Y-axis is along AY, right? What is the distance of AX? What is the distance of AX from y-axis? AX is passing through y-axis, so the distance is 0. So AX has no effect. AY is parallel to y-axis, so it has no effect. AZ, though it's perpendicular to y-axis, again, AZ is passing through y-axis. And MAX and MAZ are respective moments with respect to X and Z axis, so we don't even consider that when we're talking about y-axis. What about 80-pound force? What about 80-pound force? 80-pound force is with respect to y-axis. What is the distance of 80-pound force? It's 1.5 feet away from y-axis, right? This line is 1.5 feet away from y-axis, and it is, how is it rotating? It's giving a rotational effect, and that would be like that. And what is the direction? Is given by the 80-pound force, right? So with respect to our I, which is on the positive y, how is it rotating? It is giving a clockwise rotational effect, and that effect is 80 times 1.5, and because it is clock, I'm going to write negative. What about TC? What about TC? TC is giving an effect like that with respect to positive y. So if we are standing on the positive y direction, that means if you're standing here and we are looking at the problem, if we're looking at how TC is trying to give a rotational effect, it is trying to twist the rod counterclock. So it would be TC times 3, right? So we give that to be plus, because it's a counterclock, TC times 3, that's it, is equal to 0. That is moment with respect to y-axis. Last one, moment with respect to z-axis. That would be, what is the moment with respect to z-axis? We have MAZ, and I assumed it's going counterclock with respect to I, which is in the positive z direction. So you have to imagine yourself standing or yourself viewing this problem from the top, and MAZ is giving a counterclock. And let's look at all the forces. What about AX? AX is passing through Z, no moment, because the distance between AX and Z axis is zero. Similarly, AY and Z axis is zero. MAX is moment with respect to X axis, so we will not even consider that. AZ is the one that is parallel to Z axis, so it will not cause a rotational effect. 80 pounds and TC, they both are parallel to Z, so they will not cause any rotational effect. So for something to cause a rotational effect, it should have been, for something to have caused a rotational effect, it should have been, a force should have been like that, for example. Then this should have caused a rotational, this should have caused a rotational effect like that around Z axis. So we don't have any force of that nature. So we just are left with MAZ. So MAZ will be 0. That's it. We have 6 equations and 6 unknowns. And if you observe, we already solved for 3 unknowns here. MAZ is 0, AY is 0, AX is 0. So let's go here and apply and find out what is TC. TC is going to be 80 times 1.5 over 3, which will be 40, right? 40 pounds. So plug in TC here, then we get MAX is going to be 80 times 6 minus 40 times 6, which is 46, 240 pound-feet. Then plug in TC here, then we get, plug in TC, plug in TC here, then we get AZ to be 80 minus TC is 40, so you get 40 pounds. So we found AZ, we found MAX, we found TC, right? That's what we found out. Okay, that's the answer for this problem. We got AZ to be 40, tension is 40, and moment with respect to x-axis at A is 240 pound-feet. So this is the reaction moment, 240, 240. We got a positive answer. You see, we assumed mx is going counterclock with respect to positive x-axis, and we got a positive answer. That means our assumption is correct. So that is how we do this problem.
So if you look at this example problem, I'm waiting for this to sync. If you look at this example problem on the left hand side, so that is a uniform plate which has a weight of 500 pounds. So there is this weight, £500, and the weight acts at the center of gravity. That means here it's going to act at the center of the plate. So the center of the plate is 1.5 feet away from x-axis, right? So if we have the plate, the plate weight is 500 pound and acts at the center of the plate. That means this is if this is x-axis, this is 1.5 feet, this is 1.5 feet, because the total is given as 3 feet. And here we can assume there is a tension TC, and here we can assume there is a tension TA, here we can assume there is a tension TB, and there is a 200 pound force acting and this is at 2 feet. That means even the weight is 2 feet from y-axis, and this is the z-axis. So in this problem, can you apply sigma fx equal to 0? Though this is true, there is no force in x-axis, along x-axis. Every force is along z-axis, either positive z or negative z. So this equation is not useful. Sigma phi equal to 0, even this equation is not useful. Only equation that is useful is sigma fz is equal to 0, where when we write sigma fz equal to 0, we can write TB, positive TC, positive TA, negative 500, negative 200 is equal to 0. At least this equation is useful for us. And moment, sigma moments with respect to x-axis should be 0, implies tell me all the moments with respect to x-axis. With respect to x-axis means TB has no effect because TB lies on x-axis and perpendicular to x-axis. So the distance between TB and x-axis is 0 because TB lies, line of action of TB lies on x-axis. That means the distance between this line of action of TB and x-axis is 0. For example, if TB was acting there, we would have had some distance. This is the distance. We would have had some distance, right? Now we didn't. We can't. We don't have any distance. So what about TC? Yes, TC has an effect because TC is away from x-axis and perpendicular to x-axis, and it is like that. And what is the direction? Direction points along TC. So just follow the arrow. Just follow the arrow. And where is the point of view? Point of view is on the positive. That is where our eye is. So that is the point from which we are observing things. So TC would cause a counterclock rotational effect. So you would write positive TC times, what is the distance of TC from x-axis? 3 feet. It is 3 feet away. Similarly, what about 200 pound? 200 pound is rotating clock. The direction, we just have to follow the arrow of 200. So 200 is going clockwise. So that will be 200 times 1.5. So it will be negative 200 times 1.5 because it is clockwise. What about 500? Is also clock. So it is negative 500 times 1.5. Oh, wait a second. Why did I write 1.5 for 200? 200 is 3. The distance between 200 and x-axis, line of action of 200 and x-axis is, so 200 is like that. 200 is 3 feet away from x-axis. but 500 is 1.5 feet away from x-axis, and it is giving a clockwise. Even 500 gives a clockwise rotational effect. The direction is going down. What about TA? TA gives a counterclock. TA gives a counterclock rotational effect. So it is positive. Positive TA times 3 is 0. Then sum of moments with respect to y-axis should be 0, implies sum of all the moments with respect to y-axis equal to 0, implies what? Let's look at that. With respect to y-axis. Now, whenever we are saying with respect to y-axis, where is our point of view? The point of view is on positive y, and we are observing things with respect to y-axis. So this is y-axis. So with respect to y-axis, how are things causing rotational effect? Let's start from TB. Let's start from TB. What is the distance of TB from y-axis? 4 feet. So this distance, that is 4 feet. And does it cause a rotational effect? Yes, it does. And it does like that. And it gives, with respect to our eye, it gives a clock, right? We are here. And with respect to us, it gives a clock. So we have to imagine things because it's a 3D problem. So it is TB times 4. It's a clock, so it's a negative. Similarly, negative TC times 4. So this TC is 4 feet away from y-axis, and it is going to give a clockwise, and we have to follow the arrow. If the arrow is like that, we have to just keep following that clockwise with respect to positive y. What about 500? 500 will give a positive because it's a counterclock with respect to y-axis. You have to follow the arrow. If the arrow is like that, the arrow goes like this. So it's a positive 500 times 2. Similarly, positive 200 times 2. And what about TA? TA lies on y-axis, so it has no moment, and that is equal to 0. That's it. So we have 3 equations. Equation number 1, equation number 2, equation number 3, and 3 unknowns. So can you solve the problem? Yes, we can. What are the 3 unknowns? TA, TB, TC. We have to plug into the calculator. When we plug into the calculator, we should get TA to be 250 pounds, TB to be I think it's not going there. TB, I think we should get 350 minus TC, so we should get 100. And TC should be if TA is I'm just looking at the solution. On the left hand side, it seems TC is 100 pounds. I'm sorry, let me erase all of this. So the solution is that TA is 450 minus TC. So TA seems to be 350, and I think this is a typo here. I should have written this as I think this is TB, I guess. 350 minus TC. This is TB. Okay, just correct that. So the answers are here. So we have to plug into the calculator. You have to know how to use the calculator to solve for three equations, three unknowns, and get an answer. Okay. So with that, if we proceed further, if you look at this problem, a rod AB is supported using two cables at B and a ball and socket joint. Ball and socket joint at A means it is free to rotate with respect to X. That means like that with respect to Y. So if this is Y, that means it is free to rotate like this with respect to Y, and free to rotate with Z. That means if this is Z, it is free to rotate like that. So no moment reactions, but because translations are prevented, you have Fx, Fy, Fz at A. That means you have three reactions at A, and two ropes, so you have two reactions. That means you have five force reactions. That means the answer should be B. So let's solve this problem. So now, if you look at this problem, first thing is you should develop your ability to draw the free body diagrams. So you have to draw the free body diagrams. That means there is this bent rod. So you have a rod, So this is the rod. So this is A. At A you have, if you read the question carefully, it's a smooth journal bearing. Smooth journal bearing means it is not a thrust bearing like the problem we have solved in the previous examples, in one of the previous examples. It's a thrust bearing. That means this can go in and out. For example, at B it allows in and out motion, at C it allows up and down motion, and at C it allows free rotation with respect to Z axis, Z. At B it is free rotation with respect to X axis. At A it is free rotation with respect to Y axis. But if you remember the point I was telling you, I think a while ago in the slides, which is this: if there are two or more properly aligned bearings, only force reactions are generated, no moment reactions. So are there two or more properly aligned? Yes. A, B, C. What is the meaning of properly aligned? Properly aligned means, for example, if B is also similar to A here, C is also similar to A there, the rod can go in and out if A, B, C are all in the same line. That means there is a possibility for the rod to translate in and out. But here, is there a possibility for the rod to move for this bent rod starting from A all the way to C? Can this whole system move in X direction? No, it can't, because at B there is a reaction in Y. There is a BY and BZ at B. So if we see at B, let's talk about B. At B, the support will prevent it moving in BZ. It will support it to translate even in BY. That means the whole system cannot translate in BY direction. What about C? At C, it will again not allow it to translate along CY. Also, it will not allow it to translate along CX. At A, it will prevent it from translating along AX and AZ. okay, with, along AX and AC. So if we can take axis to be, let's say axis is there, we can take this is obviously y-axis. We can take this to be, you can take that to be x-axis. I think I'm waiting for the program to sync. And we can take going up to be z-axis. And let me give the dimensions in the meantime where it gets synced. Yeah, it got synced. So you have AZ, AX. So does the whole system translate along y direction? No, it doesn't. So does the whole system translate along z? No, it doesn't, because you have BZ and AZ, they prevent it to translate in z. So that is why when this is called properly aligned journal bearings, if we have properly aligned stuff, they prevent the system from rotation. For example, the rod, the bent rod from A to C, can it rotate? No, it can't, because of the reaction forces that we drew. They prevent it from rotation, they prevent it from translation. So this can withstand any type of loading successfully. So if this is the case, we don't require to represent moments if we have two or more journal bearings. Remember that. So if we have, in this case now, we have to give the dimensions. So let me give dimensions in a different color. Similarly, if this is CY, what is the height? This would be the height, isn't it? Which is 2 meters. This is 0.75 meter. This is 1 meter. This is 2 meter. So I think we gave all the dimensions, we gave the axis. Then we can apply the equations. Sigma fx equal to 0. Tell me all the forces in x. We have ax plus cx is 0. Tell me all the forces in the y equal to 0 implies all the forces in the y are by plus cy equal to 0. Tell me all the forces in the z equal to 0 implies az plus bz is equal to 0. Sum of moments with respect to x-axis is equal to 0 implies, tell me with respect to x-axis. Now we have some experience in the previous problem. With respect to x-axis, this is the x-axis. What is the distance of AZ? AZ lies on x-axis, it's 0. AX is parallel to x-axis, so no moment. What is the distance of BZ from x-axis? BZ is at this distance, and that distance is 2. So BZ times 2. Now it's a clock or a counterclock? So BZ is like this, rotating like that with respect to our I on positive x. And what is the direction? Direction, we should have direction of the arrow of BZ. So if BZ is going up, BZ is going like this. So with respect to our I, we have to imagine it is going counterclock. So it's a positive. So we write positive BZ times 2. What about BY? What is the distance of BY from x-axis? You may be thinking, even the distance of BY is 2. You're wrong. What is the distance of line of action of BY from x-axis? What is line of action of BY? Line of action of BY is, this is line of action of BY. This is the line. What is the distance of this line from this line? This is the line of action of BY. This is the line of action of BY. What is the distance of this line from this line, x-axis? 0, because line of action of BY lies or intersects with x-axis. So it is 0. So you don't have an effect of BY. What about CY? Unlike BY, CY is above XY plane, isn't it? CY is 2 meters above XY plane, because this is CY. Isn't this the line of action of CY? If that is the line of action of CY, then from x-axis, it is at a distance. If you take this, is at a distance, that is a distance. So it is 2 meters above, it's 2 meters above x-axis. And CY gives a moment like that, and the direction is like this, because CY direction is going to the right. So the direction is like that. That means it is clock, isn't it? It is a clockwise with respect to our I on positive x direction. That means it is CY times, it is minus CY times 2. Right? What about CX? So what about CX? CX is parallel to x-axis, so there is no contribution to moment. That means moment with respect to x-axis is, that's it. So this should be equal to 0. So moment with respect to y-axis is equal to 0 implies, what is the moment with respect to y-axis? With respect to y-axis, AX lies, the line of action of AX passes through, the line of action of AX passes through y-axis. So the distance between AX and y-axis is 0. The distance between AZ and y-axis is also 0. What about distance of BZ from y-axis? BZ is at 1 meter and it is rotating counterclock. The direction is given here. That means for y-axis we will write BZ times 1 and its direction is like that. It has to go through BZ. The circle will go through BZ and the direction is given there. And this is BZ times 1. It is a counterclock because our I is on the positive Y. So I'm going to write this is positive BZ times 1. What about BY? BY is parallel to y-axis, so it has no effect. What about CY? CY is parallel to y, no effect. What about CX? the line of action of Cx is like this, and it is above y axis by 2 meters. So Cx will have an effect like that, and its direction is like this. How did I come up with the direction? Because Cx is going to the left. So see, the line of action of Cx is like this. So we have to follow the arrow. That means it is also counterclock. So Cx times 2. So I will write this as positive Cx times 2, and that's it, equal to 0. What about sum of moments with respect to z-axis? Equal to 0 implies, with respect to z-axis, ax and az lie. Az is parallel to z, no effect. Ax passes through z, so no effect. So what we have left is by. So by is like that, line of action of by is like that. So how does by rotate with respect to z-axis? So this gives a rotation with respect to z like that, and by, isn't the direction of by going along positive y? That means on the circle, isn't the arrow supposed to be like that on the circle? That means here we have to follow the circle. That means if you're looking at this circle from the positive z, how does it appear? It appears as if it is rotating clock. And the distance is this. How much is that distance? By times 1 meter. So it is negative by times 1. What about bz? Bz is parallel to z, no effect. What about cy? Yes, cy has an effect, and from z, cy is there. That distance is 1.75, isn't it? What is the distance? This distance, that distance is 1.75, and that is exactly the distance we want here, which is the same as 1.75. So BCY is 1.75 away from z-axis, and it is rotating clock as well, because the direction is like this for CY. So if we complete the circle, so we have to follow the direction here, we have to follow the direction there, so it is clock. So CY times 1.75, so it's a negative CY times 1.75, and we have CX. What is the distance of CX? Now tell me about CX. What is the distance of CX from z-axis? This is how CX is, right? How far is CX from Z? So assume that this is the plane. How far is this line from that plane? I want you to tell me that distance. Isn't it 2 meters? Isn't that 2 meters? That distance is 2 meters. So CX is 2 meters away from Z-axis. So CX is 2 meters away from Z-axis, and Cx is going to rotate. This is Cx, this is Cx. So that would be Cx, that would be Cx, that would be Cx. So that would be rotating, even that is clockwise. So you have negative Cx times 2, and that's it, equal to 0. So these are the 6 equations, and we have 6 unknowns, and the unknowns are Ax, Cx, By, Cy, Az, Bz. Those are the 6 unknowns, and we have to solve the 6 unknowns using 6 equations. That means we have to find out one variable in terms of the other, substitute that into the other equation, and keep on doing that until we find what is Ax. That means here we can find what is Bz in terms of Cx. That implies I can say Bz here is negative Cx times 2, or I can say it is nothing but negative 2Cx, right? So Bz is negative 2Cx. Then wherever I find Bz, I'll write it as 2Cx. Now I can find Cy in terms of Cx. So that implies Cy is equal to Bz from here, because I can cancel out 2's. So that implies Cy is negative 2Cx, because Bz is, we just found out that Bz is negative 2Cx. That implies Cy is negative 2Cx. Then we will plug in Cy into this equation. That implies we can write negative By, negative Cy is negative 2Cx times 1.75, negative 2Cx is equal to 0 from this equation. That implies what is By? By is 2Cx times 1.75, negative 2Cx. So how much do we get? So I get By is 1.5 Cx. Right. But all of this problem you have to, so for this free body diagram I only took the supports into effect. But if you observe carefully, in addition to the supports, what we have is this force F, which is 800 Newton. And we have to split this 800 Newton into the x-axis, into y-axis, and into z-axis. So x-axis will be 800 times cos 60 times cos 30. It's a type 2 problem. Z would be 800 times sine 60. This is Newton. All of this is Newton. And y-axis will be 800 cos 60 sine 30 Newton. So I removed the 800 Newton force, and I can write 800 Newton force in terms of its components x, y, z. So for the same problem, So because till now what I explained to you is when I have a free body diagram without the external force, this is how we solve. But if I have an external force, what will happen to sigma fx equal to 0 now? The new sigma fx in terms of ax plus cx, you will have plus 800 cos 60 cos 30 equal to 0. Same drill. What about fy? by plus cy plus 800 cos 60 sin 30 is equal to 0. What about az? az plus bz minus 800 sin 60, because it's going down, 0. Right? What about moment with respect to x-axis? In addition to whatever you have here, you have, so that means we have to erase all these things. We have to also include the effect of the external force, because now I added external force to the system. That means in addition to that, with respect to x-axis, what we will have is this 800 sine 60, right? 800 sine 60 will be sine 60 times 2, and it is going clock, so it's negative. It is going clock because due to this externally added force, it goes like that, and we follow the arrow. So the same drill, we just have external force. What about 800 cos 60 cos 30? What about this? Because this is parallel to x, we will not have that effect in the x-axis. What about 800 cos 60 sin 30? Cos 60 sin 30, the line of 800 cos 60 sin 30 is passing through x-axis, so we will have no effect. So this is supposedly equal to 0. Then what about moment with respect to y-axis? With respect to y-axis, you see whatever equation we have there will remain the same, because 800 sine 60 passes through y, 800 cos 60 cos 30 passes through y, and this is anyways parallel to y. So those three will not have any effect. Though we add an external force, that will not have any effect. What about moment with respect to z-axis? So this remains the same, but the z-axis, it's going to change slightly. What is the moment with respect to z-axis? Because we have this force and that force. By the way, this force actually passes through this force that passes through z-axis. The line of action of 800 cos 60 sin 30 passes through z-axis, so that will not have an effect. But we will have an effect of 800 cos 60 cos 30. And that is going to rotate clockwise. It will rotate clock like that. The direction will be like this, like that, like that. So it will come back like this, because this is the direction of 800 cos 60. So the distance will be 2 meters. That means due to this addition of external force, what we will have is, we will have 800 cos 60 cos 30 times 2, and that is going clock, so it's a negative equal to 0. So this is the updated equations when we have an external force acting on the system, right? So this is how we approach the problem. By the way, I'll not give this kind of lengthy and complicated problem in the exams, but if you're able to solve a problem like this, you should be able to solve any kind of problem. If you understand this problem, you can understand any other problem in 3 dimensions with the supports. With this, we are finished with how to express supports as equivalent reactions and how to solve the problems. Okay.